Okay, great. So good good evening, good afternoon. Um, we're gonna do some exam prep work for you guys. Um, Basically looking at um, last year's exam paper. So the October, November paper of last year. Um, Going to go through a few questions. Basically, the next session we will complete this paper and then we will because you guys are only writing in November, we will have more sessions, but I will also then cover some other exam papers in those sessions. Okay, so I decided to look at the October November one and of last year, and what for me was interesting is to see how it started off with some of your last study units questions first, and then it went into some simple interest, and so I just thought quite interesting to see the different dynamics in this exam paper. So that's why you you'll see with the next one as well when I look at, I think it was last year's um, supplementary exam paper of Jan Feb. I'm going to use that one next, and just so that you guys can see all the different types of how they ask and what questions are coming up. Okay, so just for the guys joining a bit late, what we're going to look at is last year's exam paper as prep for today and our next session. So also what is included in these slides is some of the answers will be there with if you're using uh, HP or Sharp, some of the data calculations will also be there. But for this one, um, I thought I will rather use Excel. So I'm just firstly gonna open it up here on my side. Then I will bring it back to the big screen now. Um, and again, it will be interesting if you guys can just, um, I don't know if they have already told you, or you, I think you guys did the mock exam, and it was definitely not Iris that was used. It was the other one. So just would just be interested to know um, what are the how are you writing with what those things are. But so what I've now done is, and there are ways to do this in your financial calculators as well. But I just put in the data, so you can see it's exactly the same data that I used. And then I just want to work out what the correlation is. And in Excel, there is a nice correlation function, um, which just asks you to put in the two fields, and then it will work out the correlation for you. So you can see the correlation R have been worked out. It's minus 0.72766. So minus 0.72766. So in this instance, our answer would have been option C. Okay, so all that I just did, and that would be nice just so if the lecturer have given you an identification or an idea if you are allowed to use Excel or not. Else, what you guys will do is we will also be able to put it into your HP or into your Casio or Sharp, depending on what you guys are using. And then we will just need to put it as the data of the X and the Y and go step by step, going through the 5 data points that you need to put in. And then if you also then I work with a HP, then there is on the buttons you will see, and in my case with the HP, number 4, there is your R that you can use as well. So please let me know if Excel, you guys are allowed to use Excel, and also in your exam, what is the tools that you're writing under? So is it Iris that you're using, or is it a different one that you are using? Okay. So the first question was about you needing to work out um, what your correlation coefficient is, or your R. In this instance, it was negative 0.7277. What they can do is ask you if it is a strong or um, relationship. Is it a strong positive? Um, so the next question is going into something like that. What is nice about this paper and is that they didn't expect you to use this answer to say, because if you were wrong here, they didn't then get the follow-up question using this number. They give you a new point and say, what is a linear correlation coefficient of R that is equal to minus 0.91 that has been calculated for the data set mean. And then they give you 4 options. So what would you guys have said? Minus 0.91. Maybe I must just let me check if I can. What is this? I just want to see. Okay, so what would you have said for minus 0.91? Non-linear relationship between two variables are strong. Linear relationship between two variables are strong but negative. Linear between two variables are weak. Linear relationship between two variables are strong and positive. Okay, so A, B, C, or D. Think about it a bit. I know it's one of the last study units that you guys did. Might not have looked at this too much, but just type in what you guys would have said is your answer to this one, and then I will also explain to you the answer.
I would have said B.
Okay, B.
Yeah.
Okay, perfect. Okay, so beyond the watch out that this is not non-linear. It is a linear, so R, and they also tell you here linear correlation. So definitely linear relationship. It is strong, so anything from around 0.6 upwards, positive or negative, is strong. And then obviously there's negative with that. So spot on. Linear relationship between two variables are strong but negative. Okay, so here the strong was correct, but it's definitely not nonlinear. The linear relationship between two variables are weak, so it's not weak. The linear relationship between two variables are strong, which is correct, but it's not positive. Okay, so perfect on that one. Okay, and this was weird because normally one and for you guys as well, when you prepare for the exam, it's nearly, I'm used to seeing that you get your simple interest first, and then you go into compound, and they mix that up a bit. But this was nearly the first time I see exam paper that started with study unit 8 as your first two questions. So I just thought that was very strange. And it might just have been nearly to, because I would have been, when if I was writing and I'm getting this, nearly a bit uneasy, because you nearly feel that you are, it's not the path that you normally are used to. So just be not careful, just realize that they can can ask for questions in a different flow of questions. Okay, so then they ask us, and again, it's nearly not yet our simple interest question. So John's investment of 1,050,000 in the Keep the Ball shop is expected to yield the following sequence of yearly cash inflows over the next 6 years. 350, 320, 240, 500, 80, and 60,000. And then they want you to work out what is the internal rate of return. Okay, so once again, that you are able to use your financial calculators. I am going to again in the next slide nearly show you how to do that. I just want to check if there is an internal rate of return in Excel. Okay, so again, just want to give you all the options. Um, so let's just, with cash flows, just want to type it. I'm going to then show you what I would have done from Excel point of view, so that we just have all the options for you. That's 350,000, 320,000, 240,000. Let me quickly show you guys on Excel what I'm busy with, and then so I just want to check why this isn't working. Um, internal rate of return. Okay, but yeah, so this is strange because it does. I really don't. Normally that doesn't happen. I will check this out for you, so that I can just share the internal rate of return formula with you guys as well. It might just be that my data is not right. But what we can also do, and that's why I have included this set as well. So let me just in here at what we started, 1050123. But it's not supposed to, like, oh, okay. So you can see with your HP, what we do, you can put in those information numbers. We put it under the CFJ, which is nearly in the third row from the top in the middle. In the sharp, there is also one that you basically use the data function for. So by both of them, if you just put in the data, you will get the internal rate of return as 15.25. So what I also wanted to show you guys here, so what was it, 15.24. So if you use the Excel format, you actually don't need those numbers. So I'm just going to clear that. You take your cash flows. You start with a initial investment, and there's your 6 payments that you're getting. You go to internal rate of return. You will also be able to work it out with that. So again, will just be nice if you guys can just find out or let me know if you're allowed to use Excel. But what I will in any case do is I will share on the WhatsApp group. I will share you guys the Excel that we're using tonight. For the guys that's not on the WhatsApp group, please send me a WhatsApp and I will add you on 0837908387. So I will then share in any case tonight's recording, the presentation and everything with you guys. Also, I will share link to all the other videos that is on my YouTube channel that you guys can also look at previous exam preps and things like that. Just the more access you have to things, the easier to just check what types of questions they are likely to ask. Okay, so let's go into the next question. And now finally we start getting to the simple interest questions. So it took nearly at the fourth question only. And then also what is interesting, and this was, I thought the first time I have seen a question like this. So it might have been in one of your assignments, a question like this, but first time I see something like this in an exam where you are looking at a simple interest question, but you need to actually work out the amount or the time that it will um, be borrowed for or that you will pay back, but it is nearly in days. So a lot of time we will, the time might be that you need to work out the time, and then it is like 2 or 3 months or something like that. But in this instance, you actually need to work out um, what day will be the final payment. So let's look at this question. An amount of 4,317 rand and 26 cents was borrowed on 5 May at a simple interest rate of 15% per year. When will the loan be worth 4,500? Okay, so it is a bit different. Um, so let's quickly, if I look at the simple interest rate, you have a present value, you have a future value, and then we will need to work out the time. So you can work with this. If I'm correct, that is normally your simple interest formula. So we've got P, we've got your interest 0.15. We will need to work out N, and we've got your future value. Okay, so now it becomes a bit clearer. Nearly now you can see this is something that you probably would have done before. And remember, simple interest, so we can't use your financial calculators because they only focus on compound interest, so you can't use those built-in functions. So now it's nearly to say, okay, we will need to change a bit what the object of this formula is going to be. So divide by 4317.26. So you could have, to make it easier at the beginning, nearly have said, okay, how are we going to make this simplified so that we can get to N, or you can during the process do that as well. Then one will nearly take minus N on both sides, so that falls away. So let's, at this point, work with a smaller number. So 4,500 divided by 4317.26 will give me 1.0423. And if we subtract 1, we get on this side 0.0, sorry, 4233. I'm just going to keep it at that. And on the other side, still equal to 0.15n. Then we need to divide by 0.15 to isolate n on its own. So I get that n is equal to 0.2822. Okay, so that is now interesting. So does that tell us? If you get n is equal to 0.2822, so n is per year, so we will need to multiply the 0.288 by 365, and then you will get that your n is equal to 102.99. So we know actually that we will round it off to 103. Okay, so what I have done here is just to show you also exactly the same process. So you could have, and that's what I meant by, you could have isolated it from the start and then start substituting. You will still get the 103 days, but now you need to nearly go to that table that has the, when we look at counting of days. And now you need to go to where 5 May is, and you need to then say, well, that number plus 103 will give me the answer, which is then 16 August. Okay, so if you basically go to that table to where 5 May is, and you add 103 to that, you will get your answer. Let me just correct this again. You will get your answer of 16 August. What I think is also important here is that they didn't, because it's the 102.99 for 103 days, they didn't give you your options of 15, 16, and 17 August. Okay, so they will not give you that because, once again, you could have decided that I only work with a full day, so maybe I work with 102. Then it is, okay, 15 August, and then you're like, okay, but then the 16th August is the closest. So they will not give you options of 102 days, 103 days, and 104 days just because of rounding off. So I think that is just important, that again, for your answer set, yes, we normally round up, but if you worked under the impression that you only want to work with full days, and you used 102, there will not be an option for you, so that you they need to say, okay, but let's round it up. So they will not be nearly that inconsistent and give you that as an option, because that again is not fair, because depending on how you want to round it up, you might decide you don't want to use, or you only want to use full days that are completed. Okay, but yeah, like I said, this was nearly the first time in a paper I've seen something like that. We normally end off with this, where the final answer is given as 0.28 years, or maybe we need to say how many months or something like that. So it's the first time that I've seen in a paper that you actually need to say when will that future value date be. Okay, so a bit of a difference, and I think that is why this one also, just look at it later again. that's why I think we're gonna work through a few extra exam papers still, but nearly just to see what's all the types of questions that they can nearly ask you guys. So we will cover a few different aspects. Okay, so now we're going into the question of simple discount. So now it feels like we're working at least with the things that we started off with. So a bank simple discount rate is 12%. You need to pay the bank 5,000 Rand in 6 months' time. The amount of money that you will receive from the bank now. Okay, so first thing that I nearly want you guys to see, and again, we don't have the answer yet, but you need to pay the bank 5,000. It's discount, so what you will receive now is less. So just option B, we can eliminate because it needs to be less. Okay, so it's not going to be more than 5,000. It's going to be less than 5,000. And then you see these options are very close to one another. So it's nearly 16 Rand, 8 Rand apart. So it can be again any one of these. So let's work it out. Again, I want to really show you. So we've got the formula. I have found a summary formula sheet that I will share with you guys. I just want to check this week through it to make sure everything is in there. But I will share what I have found with you. That covers all your formulas that you need to know and can use. Okay, so we've got the formula of P is equal to S1 minus dt. So we know that the S is 5,000 because they say that is what you need to pay back in 6 months' time. Then they tell us the discount rate is 12%. And remember, in 6 months' time, so 6 months is 6 over 12. You could have also gone directly to 0.5 because that's half a year. And then if you work this out, you will get the 4,700 as your answer. I have seen this question, I think, in the year they use it in your exam, they used it in a few other exams that had simple discount. So what I will also see is if we can maybe get some of the other mock exams from other subjects that focuses on this as well, and there might be some questions that they use across the different areas for decision making sciences. Okay, so this one, simple discount, you basically just need to work out what the beginning value is of the discount. Again, sorry, there was just a mistake in my, if I add it, it's actually not simple discount, but simple interest. So the things with a simple discount is, and when we look at more to this formula, they can change it a bit. So here we needed to work out P. They can give us that answer that we need to work out S. What they can also do, and that I've seen a few times, is that they actually give you the two values for S, and so the future value and the present value, and they ask you to work out the discount rate. A few ways that they can tweak this question. Okay, next question. Let me ask any questions up until this point. Again, I will share the presentation, I will share the recording, I will share the Excel as well. And then also, if you guys can just in the chat, I have the exam date still as, I think, 8 November. If you guys can just in the chat says, tell me what the, if that is still the exam date as I had it when it was a preliminary exam date. Okay, so simple discount. Again, you will get a question on simple discount. You will get your question on simple interest. You will get your question on simple discount. Okay, so then again, something I don't want to say strange, but weirder, in a sense of when we look at bonds, we traditionally need, when we get to bonds, we will need to normally work out different things. And in this instance, they ask you to work out what is the value of N, the number of half years from the next coupon date until maturity. Okay, and nearly given you the two dates. So I thought with this one, look at it, nearly draw, because what I will share is nearly a time frame or timeline, and how we can get to the answers. But look at this, and maybe just quickly in the next minute jot down what you would have done and what your answer would have been. Um, I think there's, if you look at just these three options, very interesting, those two very close to one another. Um, so it might be that in between them, your answer lies, because that is just whether others are a bit further apart. These two are very close, so it might be one of those, or it might be one of the others. But just nearly quickly jot down a time frame and share what your answers would have been, um, if you needed to do this for an exam question. Okay, anybody with a possible answer? Okay, so let me share what I've done, or not what I've done, what I have. So you can see here, and you can nearly see out of these numbers. So settlement date, and then your maturity date. So if you look at your settlement date, your next coupon date from the 29th May is then going to be 8 November 2022. And then if you actually from that period up until the 8th of November 2052, that is 30 years. So that is nearly why this 30 was given, but not the answer. Remember with coupons, and we're always working in half years. So it's a 30 times 2 that will give us the 60. Okay, so a bit different question on the bonds later on. So in our next session, when we get to the last part of a paper, you will also get a question on the traditional way that the bonds are being asked. So it's not nearly being replaced by this one. It's just nearly an add-on question to bonds. Again, to be honest, I haven't seen something like this before. So this is again first time in a paper that I've seen that they are asking a question like this. So again, in this paper there was quite a few different types of questions that they have asked. Okay. What is also nearly for me that was interesting is that some of these, so this was a standalone question. It wasn't that now from here they went into your traditional, they wanted to test something with this. They're not basically repeating the question for the next set of information. So if we nearly go back to, so the first question that was on correlation coefficients or R, they ask us to work something out. Then the next one, they could have used what you worked out and said, but this is a number, but they looked at something totally separate. Again, with the the internal rate of return, normally what we will get is 2 or 3 questions based around the data. With this one, again, just one question, and then we move on to nearly a different set. So in this paper, it was very interesting how it was focused on a question, not 3 or 4 other questions that's linked to it. So again, would be interesting how this links back to how maybe your mock exam was, or that last assignment that you guys needed to do, if it was also nearly in that frame of mind it was set up. Okay, so let's look at the next question. Here we're looking at continuous compounding, where we need to work out the C. So we need to work out the interest. Again, slightly different, because you usually would get the P and the T and the C and need to work out S, or maybe you get the S and the T and the C, and you need to work out P, but seldom you need to go and work out the continuous compounding interest rate. So again, I thought a bit of a mix up in the traditional way that they would ask it, and then important that we nearly know what the formula is. So what I've done here is I've created that you already have it. So let me rewrite this. So you would see, to work out C, we need to look at ln of S over P divided by T. So if you go back to your original, remember it will be, I think, C to the power of T or T to the power of C. So the only way to nearly get that exponent to a level that we can work with, we need to take ln into consideration. So what you guys, what's important, but sorry. So what is important, and again, depending on how your calculators work, with this one on my HP, I will first need to work out the 22,000 divided by 17,500, and then will, which will be 1,2571. So then I can only work out the ln of that. So it might be that your calculator allows you to, in the type of functions, do ln in brackets S divided by P. So again, just depending on the type of calculators that everyone has, there might just be a few different steps that you need to take in between. So 1.2571 ln on my side is 0.2288. I will divide it by the 53 divided by 12. And just again, where did we get that? 53 months. So again, if they told us 53 weeks, it would have been 53 divided by 53. What is it? 53 divided by 52. If they told us it is quarters, it will be the 53 divided by 4. So just again, be on the lookout what that component is. So 53 divided by 12 give us 4,4167. Okay, so I divide that by that, and remember we need percentage, percentage, so we need to times that by 100. I get 5,1804%, 5.1804. So that would have been with the rounding off of that one, where that is different. And again, you will not get a 5.180, 5.181, 5.182. It will be definitely, there's a much wider range in the answers, which is more to do with if you worked out correctly with the T and with a lens. So it might be that if you swap those two around, you get one of the other answers. Yeah. Okay. So again, with this, unless you guys know of specific formulas on your HP or Sharp, we need to go through the process in this formula. It's not just that we can say future value, present value, a time period, and then get a interest rate, because again, what we are calculating is a continuous compounding interest rate. Okay, so again, there will be something on continuous compounding in your exam. What I have just seen again, nearly first time that I really see that they ask you to work out the interest rate. Normally, you will get the interest rate and you need to work out one of the other ones. The one that's normally the most frequently asked one is that you nearly work out the time frame. So this was for me very interesting again. Just a different way of asking it, where they normally would have asked something else in the continuous compounding interest. So again, just something to look out for. The other one that I think we also chatted about last time that you will get is a question on the perpetuities. Again, they will not tell you in the exam this is a question on that. So I just added that nearly that for your part, they're not gonna say in your exam question one is simple interest, question two is compound interest. But there will be enough things in the wording for you to see that. Okay, so let's see what is in here. Chevy has won the lotto to be paid out as he chooses. Assume that the money is worth 7.91% per year compounded quarterly. If Chevy chooses to be paid a fixed amount every 3 months for an indefinite period of time, so that is where the link to the perpetuity comes in. What amount will he receive from the lotto every 3 months? Okay, so if I can remember, the formula is normally, so your payment will be that divided by your interest. So again, we just need to check the interest that is compounded quarterly, how we will handle that. So, okay, so you will basically, you can again decide, because the formula is, okay, so your repayment nearly or payment is your the P divided by I. So you can again decide which is for you easier, to first calculate for I or to put it all together. It doesn't really make a difference. So 7.91% divided by 4 gives us 0.01978. Again, I would probably keep that in the memory of my calculator. But again, there's big differences in the answer. So it's not that if you now round this off at this stage to 0.0198 or something like that, that it will get you a different answer. Okay, so that again will not happen. Also, they will not give you an answer that is R1 difference where it could have been different. What will happen is one of these answers will be if you only divided it by 7.91%. So we can look at that. But first, let's get to the answer. So if I say the 125000 divided by that, okay, that is, okay, so let me quickly, so I was right in my first time, so sorry, where I add that, let me quickly just, now that I start working out the answer, I can see the formula was wrong that I've written down. So your repayment is per pi. So what your P would have been is R divided by I. That is your normal formula. So sorry about that. I just, and not, so to get to R, we will multiply on both sides of I. So our formula would then look slightly different. So not divided by that, but times the interest. So we will have 0.0791 divided by 4 times the 1.25 million. So that answer will be equal to 24,718.75. So again, you can now see where I rounded off. It gives you basically a 50 cents difference. So again, they will not give you another option of 24,718.75, 24,717 point. Okay, so just quickly, I just want to check if we said the 1.25 million, if we said that times the interest rate of just 0.791, if it would have been our answer, yes. So if we used that as our interest rate and multiplied it by 125,000, we would have gotten that as your answer. So again, just be very careful in the exam that you don't just use the interest, but be careful and see with what it is linked. So in this instance, that it is compounded quarterly. So if it is quarterly, you need to divide by 4. If it is monthly, divided by 12. The other one that they might include is half yearly, so it's divided by 2. Okay, so that was a question on perpetuities. Again, perpetuities will be in it, so you will get a question around perpetuities. Okay, so again, just the differences in how, again, normally we will get the monthly or quarterly payment and the interest that we get to the P. So again, just see how they have swapped it around in this instance. Okay, next question. Okay, so this one was was very interesting. Um, so here they said um, we looked at the modified internal rate of return, so MIR. Um, and they say if a modified internal rate of return, the future value of all cash flows is C, present value of all cash flow outflows is P out, are given, how can the duration of a project in years N be expressed? Okay, so what I then just did is I copied in here what the function, how it looks like, because what they want you to do is to say, how do we get to N? Okay, so if we need to make N the subject of this formula. You need to rewrite it as the subject of the formula. Okay, so just think how you would nearly go about it, and then we can look at it. So just again, nearly look at this as the formula of MIR, and how would you make N the subject of this formula? Again, this was a different a different type of question. Normally, we will get the information to work out MIR, and not this way around. Okay, so let's look at it. So what I would do first is, so we have that. So I would first try to get rid of the 1. So on both sides, add 1. So then your formula will start to look something like this. 1 over n. Then what would you do to get rid of that 1 over n? And that is nearly the important step that we need to do next, is how would you get rid of that? Okay, any ideas? Okay, so what we will do is, we will take ln on both sides, but again, we need to just be careful how we do it. So let's just do it firstly on this side. So okay, so what happens to the 1 over n if we work with ln? So what happens to the 1 over n? If I need to bring that to the front, how will that look like? because I think that is nearly the most important thing is if you take that to the front, um, anybody. What would you, in this instance, any idea what would you have guessed? Um, I don't know if it is in the study guide. You guys you didn't do differentiation and locks and those kind of things. I don't think so. So what will happen with that? Okay, so does it look like it's going to be n? Okay, so remember 1 over n will just be put in front of a ln. So if it was just say a number, it would have just been put in front of that. So what we then have here is 1 over n, there's the one ln component, there's the other ln or log component. So I need to still get n as this the subject of this. So now I've got 1 over n, still not happy with that. So if I multiply both sides with n, then on this side it will fall away. So on that side I have my n. Okay, so now at least I'm getting closer to what I need. Then the only other thing is I've got now n on this side. I need to get rid of this component. How do I do that? On both sides, I will divide by that. So if I divide on this side by ln mer, then it disappears. But on that side, then what I will need to do is to divide also by the ln mer plus 1. Okay, so it does look a bit different. So what you would get in the exam, and I just will quickly show you, is you will get, where was it? You will get, say, a group of answers. And how I would look at this every time is in this process of working it out, there's certain things that I know we can already cancel out. So when it was mer plus 1, I would have said, okay, that one where it is mer minus 1 will not be a possibility. So I would have said A would have been cancelled out just by that original one where we took 1 over, or the minus 1 over. The other one that I thought was again, so I would have looked at this and this one nearly as your two answers because it's just upside down nearly from one another. So when I will get a group of answers, I would nearly say, look at it, B and E Okay, it should have been B and D, but B and E looks very similar. The only difference is at the one, the mirror is on top, the other one, the mirror is on bottom, so it's just swapped around. So this nearly I would have said from the beginning is, it feels like it's going to be one of those two. But then as one works through and you see, okay, there's mir plus one. If there's in any one of the others a mir minus one, you can cancel that out. The same if they suddenly, one of the options is PV out over C. So if that is in one of your answers, automatically also say you can't, because there's no ways we're going to change that if we need to get to N. Okay, so, but again, this was a very strange um, a strange one, um, where where it's normally not the way that we used to being asked. So yeah, so that's why again I think this was a very very strange uh, um, yeah, a strange one where something else was asked. So there's a few minutes left. Let's see if we can complete some of these. So again, if you look at what we want to do, continuous compounding rate. So again, they've asked this one, but wait, isn't this exactly the same as the previous one? Okay, strange that they actually asked something like this twice. And this was from a previous exam. So again, one will normally not get it twice in the exam, exactly the same question, just a bit different numbers. So if you get something like this twice, um, and you're good with it, be thankful. I don't think I will make a mistake like this again this year, where you actually getting the same question twice. So let's see. So you've got your future value, you've got your present value, and you divide that by the time period. Again, 57 months. So remember, divided by the 12. Um, so we've got 85,000 divided by 54,500, which is 1,5596. And if we take the ln of that, I get 0,4445. And we need to divide that by 57 divided by 12, which is 4,75. So again, I'm going to work with rounded off numbers. So it might now be that we get close to the answer, but maybe one decimal difference. But what I get is 9.36%. Okay, so at least um, there is an answer for me. Let's just check if that is correct. in the exam, I now would have probably made a mistake because I would have not made a mistake, but if I was rushed and needed to just make a guess, I would have probably gone between those two because they are closer to one another. So again, you can't really with options all the time be clear in which way the question is going and what might be different options. Okay, so, but strange that they, in the same exam, had exactly the same type of question. Um, so, yeah, if it happens like that in your exam, be grateful if it is one that you are comfortable with in working out. Okay, so let's look at this one. It's the last one for tonight. So what we have is two things here. So Julius inherits 2.5 million. He decides to have it paid to him in two payments. One payment 4 years from now, and the other payment 3 times the size of the first payment 10 years from now. Okay, so now it is one of those. It's now one of those that you nearly need to say there's going to be amount X, there's going to be amount 10 years from now, and they say it 3 times the size of X, um, so that you can narrow that down towards what your answer set is going to be. So firstly, what I thought is, okay, so let's look at it. So the first thing happens within 4 years. So there's your first payment from 4 years. So, and then there's a payment um, after the 10 years. And what is also important is that we start off with the present value. So at that time, um, it will be 0, your future value. So the first component up until the 3x is to do with 10 years. The other component with x is to do with the 6 years. So that is very important, nearly, because when we look at the formulas, we're basically gonna do this nearly twice. Um, so we're gonna look at that 2.5 million over the 10 years period. So that would be your original future value. So if you look at it, that 2.5 million over the 10-year period, it was the interest rate of 12.25, which again, they could have kept it easier and simpler and just said per year, but now still they added the compounded quarterly. So remember then, that's why it's times 4 and divided by 4, because it is quarterly. And then your payments is, the first one is, again, if we look at that schedule, it is 6 years from the end. So your X is, again, very important, the 6 times 4, because it's quarterly. Interest need to be divided by 4 because it's quarterly. Your last payment happens in that last, it nearly ends off with that. That's where you get the 3x. So there's nothing, no interest component that you're working with that. So we need to work out what the future value is. And then with that future value, we will make it equal to the x plus a fraction plus your free x. And then when we work that out, we will get that your x is around 1650, and if we multiply that then with a free x or with free, you will get that value. Also, I think what is important, and this was very, very interesting as well, is if you look at the x, you will also see is in one of those answers. And I don't know if you guys have different exam papers. So that is also, but here they specifically said what amount can you expect it to receive 10 years from now. So that's why we are looking for the free X. It could have been, and again, be careful and be very specific when you read the question. It could have been that they asked you, what amount will you receive 4 years from now? And then that would have been the one 4 years from now. But they want to know what is the payment 10 years from now. So that is the free X component that we are working with. So just again, be careful when you work with that, because it might be that they ask you to work out the 4 years, or they can ask you to work out the 10 years. So again, there might be two different angles to this question. Okay, so that is it for tonight. We'll again, I think our next session we'll decide, as some of the other subjects end, that we get a time slot that in the end will nearly suit more people. But for this week it was today. But next week it might be a different time slot. So just again, if you can please let me know on the WhatsApp group or in the chat when your exam date is, so that we can just plan around that. And then that is it for tonight. I will again share the presentation on the WhatsApp group. I will also share the recording. So, and again, anybody that's not on the WhatsApp group that still wants to join, please do. Just send me a WhatsApp on 0837908387. I will add you. And then yeah, I will definitely post the recording to the group later tonight as well. Okay, have a good evening, everyone, and good luck with all the other exams that you guys are writing. And then we will see next week again. Okay, cool. Cheers, everyone.